Morning students, today we are going to learn about multiplication of a vector by a scalar. Let a vector be a given vector and lambda be a scalar, then the product of the vector a vector by the scalar lambda denoted by lambda a vector is called the multiplication of a vector by the scalar lambda, and lambda a vector is also a vector. Habadi nangi a vector the scalar amna multiply tawuse scalar into a vector niko, and which represents a vector which is collinear with a vector. Collinear means a vector ga parallel oiba vector amane bako, and its magnitude is given by magnitude of lambda times of a vector is equal to magnitude of lambda and magnitude of a. Habadi lambda a vector habise magnitude of lambda and magnitude of a. Lambda do plus hoigera minus hoigera plus loganiba. Example, if lambda is equal to 3 and the a vector be a given vector, and this is a b vector represent this small letter a vector, then 3 times of a vector is a vector whose magnitude is 3 times of a vector. Habadi 3 a vector habise vector amani kanada parallel oigani a vector ga parallel oigani bako. Parallel means collinear tarani aduga nangi sida 3 haisi laitaragadi a vector dugi saruk kya sangbu oiganeba, saruk ahum sangbu oiganeba. If lambda is equal to 1 by 2, nangi lambda sina 1 by 2 oitardi 1 by 2 a vector haitardi magi magnitude se kai oigani 1 by 2 a vector is a vector whose magnitude is half of magnitude of ab. Ab sigi tangkhai se sina half ab na represent tarani ba. Sida lambda gi values the depend tawiko. If lambda is equal to positive number, then a vector and lambda times of a vector have same direction. If lambda is equal to negative number, then a vector and lambda times of a vector are in opposite direction. Lambda na positive oragadi a ga lambda a ga se same direction na chatkani. Lambda na negative oragadi a vector ga lambda a ga do kai da chatkani haba opposite direction da langni. Aintaraga opposite to in la ani ba ko. Next topic, components of a vector. Vector amagi components se kamai puthokani ba. Let capital P coordinates are x, y, z be any point in the space, and let R vector or OP vector be the position vector of the point A. Kuna first the point P im laurasiko magi coordinates sing se x, y, z ni sumai taraga x, y, z ire, then complete a parallelepiped. Parallelepiped se OQ P1 A's adagi sigi value se kuna S dash kumba hapasiko, and R sina R dash hello sina P ohele sana parallelepiped ama complete to hole that P1. Let P1 be the foot of the perpendicular drawn from the point A on the karamba plane tare. This axis represent x axis and this axis represent y axis. Then this plane is the plane formed by the x axis and y axis, so it is called x or y plane. X or y plane tai ko P1 se karamba plane de lere kun x or y plane de tare. Let P1 be the foot of the perpendicular drawn from the given point P on the plane x or y plane. Then P1 is parallel to kanada parallel tani sa x axis the parallel tagani, since I cap, j cap, and the k cap are the unit vectors along kanada ektawi x axis, y axis, and the z axis respectively. We have this OR vector. This OR vector will be equal to P1P vector. Sigi OR vector se kanaga chap manani P1P vector ga chap manani. Sigi concept se box amane na khalo. Box sigi opposite leina banangi corner ani dugi length to oidene bako. Then OR vector will be equal to P1P vector, which is equal to Z K cap ka mane. Z K cap ka mana bagi maram di kaigino K cap 5 se kaigi formula na P ni K cap can be considered as a unit vector acting along the OR vector, so it is given by OR vector divided by magnitude of OR. Habadi kuna mamang da any unit vector habasa kay na define tawgre a cap is given by a vector divided by magnitude of a. Sina P do ni ko aduna k cap is equal to OR vector divided by magnitude of kay tare OR. Then sida O dagi na R box sa x sang do ni, O dagi na S box na y sang do ni, O dagi na Q box na kay sang ni kuna small x sang do ni ba aduna coordinates of P sa kanana represent awi x ne y ne z ne aduna represent awi ko. Hojik nang lairiba length se OR is equal to z, OS is equal to y, and OQ is equal to kay gamane heba x kasi concept sida ko na angka hoto ini. aduna se lagtui se this OR vector is equal to Z multiplied by K cap by cross multiplication. OR vector have se OR gi magnitude to the K cap na multiply to baga manare ko. Aduna OR have se Z K cap tare. Next, similarly, QP1 vector. Similarly, sige QP1. QP1 is equal to OS vector. QP1 is equal to OS vector, which is equal to Y, Z cap, and OQ. OQ is same as SP1 vector. OQ have say SP1 vector gamane ko, which is equal to kay gamana granima se XI cap have se gamana doing. XI cap tare. Therefore, it follows that OP1 vector. OP1 vector se puthok doing ko in triangle OQP1. OQP1 see the OP1 vector is equal to OQ vector plus QP1 vector. OQ vector plus Q1 vector habadi se triangle law of vectors pale OQ vector is represented by XI cap and then this QP1 have se ngasai kai gamanagi OS have se gamanagi dra then which is equal to YJ cap nang O dagina P1 baugi vector se XI cap plus YJ cap tare ko. Now O sigi triangle ama mukhalase ko triangle OPP1 sigi manungda. In the triangle OPP1 applied triangle law of vectors, we have OP1 vector plus P1P vector is equal to OP vector. So OP vector is equal to OP1 plus P1P vector tare ko. OP1 vector is represented by XI cap plus YJ cap and this P1P vector is represented by ngasai kay na represent over ZK cap na represent over ko, and therefore this OP vector can be expressed as combined expressed where X coordinate multiplied by I cap, Y coordinate multiplied by J cap, and the Z coordinate multiplied by K cap. Hence, the position vector of the any point P whose coordinates are X, Y, Z with reference to the origin is given by OP vector or R vector is equal to XI cap, YJ cap, and the ZK cap sinapire ko. And this form of any vector is called its component form. Sige IJ cap the express the representation of vector se kai kawi koina component form kawi ko. Component form si the vector form si the scalar haibamaga vector components haibaga anile. Here the coordinates of the point P X, Y, Z are called the scalar components of the R vector, and XI cap, YJ cap, and the ZK cap are called the vector components. The IJK involved tawraba adu itardi vector haina kawgani, IJK involved tawdragana kai karani scalar components kawgani ko. Yuna nangon the any coordinate P ma piradi magi position vector EO haitaragadi X component multiplied by I cap plus Y component multiplied by J cap plus Z component multiplied by K cap sumain tawgani. In IJK form the itopasi ki maming kai kore component form of the vector kawi ko. Now we have to find the magnitude of this OP vector. Magnitude putok to ine. In the right triangle OQP1. OQP1 say right triangle amaneba masik another right angle oi which is right angle at P1 which is right angle at. Now in the right triangle OQP1 right angle at Q. See Q the right triangle ta duine ko. See nang box amagi shape ne box to gi bottom oi duine bottom to gi corner se right angle oirani. Then OQP1 se gi right angle se Q the oirabani na koina OP1. OP1 have say Pythagoras pale ko. Pythagoras paladi OP1 is equal to OQ vector OQ square plus QP1 whole square ne duna nangi magnitude loradi. Magnitude means then square root lore ko. Modulus lobukanda OP1 vector will be equal to root over OQ1 square plus QP1 whole square tare. Then this OQ gi length se X tai ko aduga QP1 is same as OS ni. OS have a length to ding asai Y na represent or record. Then O dagi na P bao se length se kya sangi hai tar di root over X square plus Y square neba. Ado sigi angle Q si the right angle form tawi ko. Then in the right triangle OP and the P1. OP and the P1 say right angle se kai the oi hai tar di sigi P1 si the mukta ba. P1 se right angle oi tar di OP se na hypotenuse tare ko. Remaining side ani se PP1 and OP1 si na remaining side soire. Aduna therefore OP vector magnitude of OP vector is equal to root over kai gamanarani atop remaining side se PP1 and OP1 vector form the ige hai tar di OP1 vector magnitude whole square plus p1 and the p vector magnitude whole square, and this op1 vector is represented by root over x square plus y square, and squaring on both sides we have op1 whole square will be equal to x square plus y square tadoi natra. Then op1 gi square haitardi kaiga manarani x square plus y square, and this p1 and the p is same as or, and or is represented by the component z, and so the magnitude of OP vector is equal to root over x square plus y square plus kaiga manare z square tare ko, and hence the magnitude of OP vector is CP reva. Yuna nangwan the any point am piba kanda nangi component form se si mathaki se tare ko. Magnitude u heightar di which is equal to root over x component square plus y component square plus kaiga manarani z component square. So main taraga koina nangi a component form of the vector ibang ngame ko, and kai puthok pasungame magi magnitude puthok pasungame. Now let us consider any two vectors, vector A and the vector B. Components of vector A are A1, A2 and A3. Components of vector B are B1, B2 and B3. Number 1. A vector plus B vector. We can find the sum of these two vectors in the form of component form. Component form da koina sum puthokpa yaiba ko. A vector plus B vector is equal to kya ga manarani sum of their corresponding components of A1, B1 plus A2, B2 plus A3 and B3. Sina nangi vector ani plus tawbani ko. Vector ani plus tawge haitar di add their corresponding components. Number 2, A vector minus B vector. We can find the difference of any two vectors A vector and B vector by subtracting the corresponding components A1 minus B1, A2 minus B2 and A3 minus B3. Number 3, if A vector equals to B vector, which implies that corresponding components are equal, or for any two vectors A and the B, if their corresponding components are equal, which implies that two vectors are equal. Adunas the part kya sure? Ani sure ko. A vector equals to B vector if and only if their corresponding components are equal. In this case, A vector and B vector. If A vector equals to B vector, which implies that A1 will be equal to B1, A2 will be equal to B2, A3 will be equal to B3. If for any these two vectors, if A1 equals to B1, A2 equals to B2, A2 equals to B3, which implies that the two vectors are equal. So maina vector ani manaradi corresponding component manarani corresponding component manaradi vector ani do manarani bako. Roman number 4. Lambda times of A vector, where lambda is any scalar. Lambda times of A vector haitaradi kamain taune scalar multiplication of A vector by the lambda. Scalar multiplication of A vector by the scalar lambda in component form is obtained by multiplying its components of the A vector by the scalar. Yang asai A say A1, A2, A3 the thumb gidana. Lambda times of A vector haitar the A1, A2, A3 should be multiplied by this lambda. Chida koina rule kya laire? Rule marim laire ko. Next topic. Vector joining any two vectors. Vector joining any two points. Nangi point ani piraga akoina vector ama join tawbasa kaido express tawgadaba component form de express tawgadaba ko. Let us consider any two points. First point P, whose coordinates are x1, y1, z1, and point P, whose coordinates are x2, y2, and z2. Position vector of P, position vector of Q. Kamai ibayagane. Then the vector joining the two points P and the Q is PQ vector. Koina PQ vector se hojik idoineba ko. Now OP vector, position vector of P is equal to x1 multiplied by I cap, y1 multiplied by j cap, and z1 into k cap. Kaigino, write OP vector and OQ vector in component form. Component ito in the triangle OP and Q. Apply triangle law of vectors. OPQ sigi manungda triangle law of vectors apply to risiko. OP vector plus OQ vector, it will be equal to OQ vector. Here we have to find OP vector. So write this OP vector and transpose this OP vector from left hand side to right hand side. OP vector se left tagi right the transpose torase to the minus of OP vector tareko. OQ vector minus OP vector, and their components are given in the above equations. Subtract OQ vector and OP vector. OQ dagi kana subtract taurani, OP subtract taureko. Subtract their corresponding component. We have x2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. Position vector of any vector joining any 2 points is given by position vector of terminal minus position vector of initial. Nangna point ani join tawraga vector ama form tawningagadi nangi terminal gi position vector dagi kana subtract tawgani haba initial se subtract tawgani bako aduna nangi hana pq haitadi p is the initial point and q is the terminal point, so pq vector is given by position vector of q minus position vector of p, and subtract these two components and we have x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Then come magnitude of the oq vector is given by magnitude of PQ vector is denoted by PQ vector enclosed within this modulus sign, which is equal to root over x component square, y component square, and z component square. X component x2 minus x1 whole square, y component y2 minus y1 whole square, and z component z2 minus z1 square. X component the square lorani, y component the square lorani, z component the square lorani. Moi ahum se plus taurani ko aduga square root lorakani. Square root tadi plus taba yai minus taba yai, but modulus is always a positive quantity, so we should take the positive value of the square root of the expression. Positive value khatang launi ko, negative to neglect taurani. Then sumain taraga kuina vector rani join to bahirani ko. Now let's come to exercise 10.2. 10.2 deyang ase compute the magnitude of the following vectors. The period vector mayamsigi magnitude putho bako. Here a vector whose components are I cap, j cap, and the k cap. Magnitude of a is equal to root over x square plus y square plus z square niko. X component 1, 1 square is 1, y component 1. 1 square is equal to 1 and the z is equal to 1 square root over 3, and so magnitude of a is equal to root over 3. Magnitude of a represents the length of the line segment representing vector a. Distance oidenebako. Magnitude of b magi length to oideba. Magnitude of b 2 I cap minus 7 j cap and minus 3 times of k cap. Magnitude of b is equal to here x component 2, y component minus 7, z component minus 3. 2 square 4 minus 7 whole square 49, and minus 3 whole square is equal to 9 is equal to 62. 62 se kuna factorization tawusu yadre ko aduna kai tare mase root over 62 units. Then for c vector, components are 1 by root 3 I cap plus 1 by root 3 j cap minus 1 by root 3 k cap. Magnitude of c vector will be equal to x component square 1 by root 3 whole square plus 1 by root 3 whole square plus z component is minus 1 by root 3 whole square, which is equal to 1 by 3 plus 1 by 3 plus 1 by 3 equals to, they have same denominator, find the sum of numerator, we get 3. 3 by 3 is equal to root over 1. Since root over 1 is equal to 1, magnitude of c is equal to 1, which implies that c is a unit vector. C is a karamba vector or a unit vector ko. Now question number 2. Write two different vectors having the same magnitude. Magnitude samanaba vector ani iyo ko. Let us consider any two vectors A. I cap plus j cap minus k cap. B vector equals to I cap plus j cap plus k cap. See, coefficients sing samanaba duga magi sign the kar khena lasiko. Magnitude of A 1 root over 3. Magnitude of b is equal to 1 root over 3. Therefore, the two vectors having the same magnitudes are vector anisi oibe. Sinataba topa mayamam silebiyai ko. Koina kamay logani haitardi plus minus kaktang the change tawgani atuga atopa coefficient mayam sinangi numeral value sing siloi mana haloba. Next question number 4. Find the values of x and y so that these vectors and these vectors are equal. The vector ani manai haina pire. Aduga kai value holo haiba. Find the values of x and y niko. Here, vectors given in left hand side is equal to right hand side. If the two vectors are equal, then corresponding components should be equal. So x should be equal to 2 and the y should be equal to 3. These are the values of x and y. Now question number 5. Find the scalar and vector components of the vector with initial point coordinates 2, 1 and the terminal point coordinates minus 5, 7. Here we have to find the scalar and vector components of a vector whose initial position is 2, 1 and terminal point is -5, 7. Now let us represent these two points by the 2 points. These two coordinates by the 2 points. Nangi coordinate anise. Point ani na represent the whole call. Let A represent the first component 2, 1. First coordinate 2, 1 and B represents the second coordinate -5, 7. So main taraga point ani na represent the whole dana. Then form AB vector. AB vector se puto. AB vector right are deep. Terminal is B, initial is A niko. So position vector of B minus position vector of A tare. Position vector of B component se -5, 7 niko. -5 I k plus 7 j k minus. Position vector of A will be 2 I k plus 1 j k. Masai takre ko. Magi coordinates sing sida first na I hapsilo, second na j hapsilo, third yara magadi k hapkadavani. Then subtract these vectors. -5 and -2, it will be equal to -7 I cap, 7 -1, it will be equal to 6 times of c. And these are the components of AB vector. Therefore, the scalar components of AB vector are scalar means the real number niko, -7 and 6. -7 ka 6 ka se magi scalar components ni and vector components are the kaitarani. And the vector components of AB vector are -7 I cap and 6 j cap. Scalar iba ngame ko, vector iba so ngame. Question number 7. Find the unit vector in the direction of the vector. A vector equals to I cap plus j cap plus 2 times. Okay, see important question ni. Here koi exam de am hangbo question ni ko. Let A vector represents the given vector, or A vector is the given vector. Now on the vector ampere. Vector sigi components in say I cap, j cap and 2 times of k cap tareko. And therefore A cap is given by the formula A vector divided by the magnitude of A. Write the components of A vector I cap plus j cap plus 2 times of k divided by root over magnitude of A. 1 square plus 1 square plus 2 square. See, my components is 1 ni. Components is 1 ni. Components is 2 ni ko. Aduna square square lauraga ito o I cap plus j cap plus 2 times of k divided by root over 6. Then right, I cap divided by root 6, j cap divided by root 6 and the 2 k cap divided by root 6. And this is a vector acting, this is the unit vector acting along the given vector A vector. A vector habiduda ek tauraga laiba unit vector sa sigi vectors na represent taureka. Next question, question number 8. Find the unit vector in the direction of the vector PQ vector where P and the Q are the points. Point ani pireko. Here the point P, coordinates of point P are 1, 2, 3. Coordinates of Q are 4, 5 and 6. Then form PQ vector, which is given by position vector of Q minus position vector of P. Write position vector of Q and the P in components form. Then how to write its component form? This X component multiplied by IK plus Y component multiplied by JK plus Z component multiplied by K minus 1 IK plus 2 AK 2 JK plus 3 times of K. Then subtract corresponding components. 4 minus 1, 3 I cap, and the 5 minus 2 is equal to 3 j cap, and 6 minus 3 is equal to k cap. Si bhange ko. These are the components of PQ vector. Now the unit vector acting along this PQ vector is denoted by PQ cap. PQ cap and which is given by kegi formula na pire PQ vector divided by magnitude of PQ vector. Then write the components of PQ 3ik plus 3jk plus 3kk divided by magnitude of PQ. Magnitude of PQ is given by 3 square 9 plus 3 square 9 plus 3 square is equal to 9 and their sum is equal to 27. Sige vector se kay orane. This is the vector acting along PQ vector. Next question number 9 ko. Question number 9, the period says for the given vectors A vector and B vector, find the unit vector in the direction of the vector A vector plus B vector. Nangon the A vector haibamaga B vector haibamaga pireba. Duga A vector plus B vector sa sida ek taraga leba unit vector ama putho o haiba. Question number 9. Here a vector and b vector are given two vectors. Then find a vector plus b vector. A ga b ga gi plus taurasi. A vector and b. 2 plus minus 1 is equal to 1. Minus 1 plus 1 is equal to 0. 2 plus minus 1 is equal to 1. K tareko. 1 I cap plus 0 j cap plus k cap. And the sum of these two vectors or resultant of the two vector is represented by another vector, say c vector. Then we need to find a unit vector acting along the sum of the two vectors, and which is given by c cap. By the definition of unit vector, this c cap is given by c vector divided by magnitude of c. I cap plus 0 j cap plus k cap divided by modulus of Sigi my components say 1 square 1, 0 square is equal to 0 and 1 square is equal to 1, which is equal to I cap divided by root 2 plus 0 j cap divided by root 2 plus k cap divided by root 2. And therefore the unit vector in the direction of a vector plus b vector is given by I cap by root 2, 0 k cap by root 2 and the k cap divided by root over 2. Sina question number 9 gi answer were ko. Last question number 10. Here the question is, find a vector in the direction of 5k cap minus j cap plus 2k cap vector which has magnitude I units. Magi magnitude se kya leba? 8 leba ko. Let a vector represents the given vector. Sigi vector se a na represent ore. Dudi sumain tawraga nangonde a vector am leni sigumba nipan sangba haiba ko. A vector sigi unit se nipan sangba kai putho haiba vector am putho kadaba. A vector in the direction of a vector being magnitude 8 units है magnitude से क्या होएगा 8 units है vector पुथोक्तोइनी का अदुना a cap हाना पुथोसे a cap is given by a vector divided by magnitude of a and 5 I cap minus j cap plus 2 times of k divided by 5 square 25 minus 1 square 1 2 square is equal to 4 and their sum is equal to 30 तारेको 5 I cap by root 30 minus j cap by root 30 plus 2 k cap divided by root 30. A cap hangbadagidi a cap haibasidi kaino a cap is a vector having magnitude 1 only. Magnitude 1 sitananga 8 pam tardi 8 na multiply tawniba aduga 7 pamagadi kaina multiply tawrani 7 na ko. Therefore a vector in the direction of a vector having magnitude 8 units is given by 8 into a cap, and 8 into a cap ki component में हमसे 0, then all the components of a vector should be multiplied by this scalar 8. 8 5 40, 8 into minus 1 minus 8, 8 into 2 is equal to 16 k cap divided by root over 30. So we can find a vector in the direction of a vector having 8 units. 8 leramagana 8 0, 7 pamagana 7 0, 5 leragana 5 itareko. For today, let's end here.